Hello friends, this session is about arrangement of electrons in elements with atomic numbers 1 to 20. Arrangement of electrons is also known as electronic configuration. So here we are talking about electronic configuration of elements with atomic numbers 1 to 20. Each element has an atomic number assigned to it. No two elements have the same atomic number. An atomic number is unique for any given element. When the atomic number is 1, is for hydrogen, 2 is for helium, 3 is for lithium, 4 for beryllium, 5 boron, 6 carbon, 7 nitrogen, 8 oxygen, 9 fluorine, 10 neon, 11 sodium, 12 magnesium, 13 aluminium, 14 silicon, 15 phosphorus, 16 sulfur, 17 chlorine, 18 argon, 19 potassium, 20 calcium. For any given element, the atomic number is equal to the number of protons, and the number of protons is equal to the number of electrons. For any given element, atomic number is equal to the number of protons, and the number of protons is equal to the number of electrons. Protons are located in the nucleus of the atom, of course together with neutrons. The neutrons are not indicated here. Electrons are located in the shells. If the atomic number is 1, it means hydrogen has 1 proton and 1 electron. If the atomic number is 2, it means helium has 2 protons and 2 electrons. The 2 electrons in helium are in the first shell, and with the 2 electrons, the first shell in helium is complete. Any other electron that comes up will have to be in a higher energy level or in a higher shell. Lithium has atomic number 3, meaning there are 3 protons and 3 electrons. The electrons are in the shells. The first shell takes 2. The first shell cannot take more than 2 electrons. Then the second shell takes 1 electron. In beryllium, the atomic number is 4, meaning that there are 4 protons and 4 electrons. The first shell takes 2 and the second shell takes 2. Electrons are added in the last shell, one at a time, as you move from one element to the other, until you get to neon. With 8 electrons in neon, the outermost shell is completely filled. Any other electron will have to go to a higher shell. Now in sodium, sodium has atomic number 11, meaning that it has 11 protons and 11 electrons. The first shell takes 2 of the electrons, the second shell takes 8, and the last shell takes 1. Progressively, an electron is added one at a time in the outer shell as you move from one element to the other until you get to argon with atomic number 18. With atomic number 18, argon has 18 protons and 18 electrons. The first shell takes 2, the second shell takes 8, and the last shell takes 8. With 8 electrons in the outermost shell, argon is completely filled. Any other electron that comes up will have to go to a higher shell. Now in potassium, potassium has atomic number 19, meaning that it has 19 protons and 19 electrons. The first shell takes 2, the second shell takes 8, the third shell takes 8, and the last shell takes 1. The next element is calcium with atomic number 20, meaning that it has 20 protons and 20 electrons. The first shell takes 2, the second shell takes 8, the third shell takes 8, and the last shell takes 2. Electrons in the outermost shell are known as valence electrons. Looking at the diagram, you notice a number of patterns. First, each element in the first row has one shell. Each element in the second row has 2 shells. Each element in the third row has 3 shells. And each element in the fourth row has 4 shells. Another pattern I would like us to notice is that when you look at a column, each element in a given column has the same number of valence electrons. In this column, each element here has 1 valence electron. Each element here has 2 valence electrons. Each element here has 3 valence electrons. Here, 4 valence electrons, 5 valence electrons, 6 valence electrons, 7 valence electrons. And what about here? Okay, this one has 8 valence electrons, 8 valence electrons. But here you have only 2. With 2 electrons, the first and only shell is complete. Here, with 8 electrons, the outermost shell is complete. Here, with 8 electrons, the outermost shell is complete. All the elements here have complete outermost shell. That is why they are in the same column. Another pattern that can be observed here is that as you move from left to right in a given row, from one element to another, 1 electron is added to the outermost shell. The last pattern we can observe here is that the electrons are added periodically as you move from one element to another with increasing atomic number. Now here, the first and only shell is complete. The cloud begins all over here with the next shell, and you move on. There, the second shell is complete with 8 electrons. Then you move to the next atomic number 11, which is for sodium, and you progress. The third shell is complete here with 8 electrons. The next electron will have to be in a higher energy level, which belongs to the element potassium with atomic number 19, and so on. Thank you very much, and see you next time.